I am Charlie Simons. Welcome to Do Not Talk, where we talk about the two things you're never supposed to talk about. It's kind of what I do, and letting you be aware of what's happening around us. Richard Lingensjo is my guest today on Do Not Talk. Lingensjo. Richard Lingensjo. Never heard of him? I know, exactly. That's the point. And his idea is completely brilliant. He's going to revolutionize, or he already has, power and energy production. That's where this guy comes in. Richard Lingensjo. Hello, sir. How are you?
I'm doing good this morning. Thanks for having me on, Charlie.
Hey, thanks for being had. That's my favorite joke. It's going to be a dark day when the grid goes down, and everybody's talking about it's happening in July. I've been hearing that. That's chatter going on. Oh, it's coming. We're all gonna go down, and there's gonna be marauders, and there's gonna be no power, and nobody will be able to get their money out of the ATMs, and everything having to do with electricity will be gone. How they have all different kinds of theories how it's going to happen. So I'm really interested in energy, and if there's a possible way to create our own somehow, or to bypass what everybody else has established as the only way to create energy. But I don't hear from those people, and often those people are silenced because the people that are creating energy for us now are making plenty of money doing that, and they don't want any competition, do they now?
Yes, they actually see me as a threat. And locally, I've attempted to get the Placer County Board of Supervisors to even allow to make a presentation on what I want to do. And the local power industry and PG&E have actually blocked some of my communication in that effort. People ask me, what does power have to do with the politics? And I think the fact that, yes, yeah, it's amazing. And I think the president of the United States, I'm reluctant to even say his name, is in California today. And that's what he's talking about, the Green New Deal. The Green New Deal that they're going to spend trillions, with a T, trillions of dollars on needlessly. Taxpayer money, of course. The government has no money. It's all taxpayer money. And so that's the tie between power and politics. And one thing that, the major thing that I would like to tell folks, especially folks who are a little anxious about nuclear power, is that what I propose doing, actually in the process of doing, I've been working on this for 4 years, is safe. It's not the water-cooled reactors that are currently in use. Okay, there's 92 nuclear power plants in the United States. All of them but 2 are east of the Mississippi. And the thing is that all of those power plants are water cooled. And all the accidents, if you've heard about Chernobyl, 3 Mile Island, Fukushima, those were all failure of the water cooling system. Okay, Chernobyl.
Those great big giant towers, that's what that is. They're just basically creating a gigantic waterfall coming down the, right?
Well, what happens is that water wants to turn to steam at 100 Celsius. I don't want to get too technical, but the thing is that water beep on your stove, that's not enough energy to turn 14-foot diameter blades in a turbine to make electricity. So what they need to do is they need to take the water to 300 Celsius. The problem with that is that you have to put it under an extreme amount of pressure to get it to 300 Celsius and keep it liquid. The thing is, though, then when it turns to steam, there's enough energy there to make the turbines go to run to make the electricity. And the problem is when it accidentally escapes, the water at 300 Celsius turns to steam instantaneously, tiny fractions of a second. It's actually a water explosion, and the volume goes up 1,000 times. At Chernobyl, what happened was it blew the lid off the reactor building, and the water that escaped is radioactive. Right. So the steam blows downwind and contaminates the damn countryside with radioactivity. And so, and then of course, 3 Mile Island, nobody died there. Chernobyl was just a silly engineering mistake. But in each of those situations, the accident was a water cooling failure. And what we're going to do is we're not going to use water. So this is like totally different. So I'm just not proposing making more water cooled reactors. They're dangerous. They've been proven dangerous. What we want to do is we want to build molten salt reactors.
I'm no scientist. In fact, I got C's and D's in what my dad affectionately called bonehead math. I am not of that kind of technical mind. But when you were describing to me how this is going to work, I was fascinated. I just thought, this is brilliant. Why is this not happening? So instead of water, you're using salt. What's the benefit of that? We do have plenty of salt, right? I mean, we're not going to run out of salt. Hopefully.
That's right. And scientists call different combinations of things salts. So it's not complicated. It's just mixing different elements together and you wind up with a salt. And so, for instance, this is Fluorex, okay? This is fluoride in a solid form. And so this would have to go to a very high temperature to melt, okay? This is like a stone, okay? And so the big difference is this needs to be around 300 Celsius just to turn it into a liquid. And fluoride, a mixture of fluoride and a salt, is what we're going to actually use to cool the reactor. And so the thing is, if I accidentally leave the door open, being facetious, and the molten salt leaks out, it immediately turns back to a solid. So it's not steam that's going into the environment. It turns back to a solid right away because it's not 300 Celsius outside. And so it'd be a mess, but the big difference is it's not going anywhere. And so that's why it's safe. And the thing is, I didn't invent this, okay? This was actually invented at the Oak Ridge National Laboratory back in 1956. And Alvin Weinberg, the guy who was the big nuke guy at the time, he ran the Manhattan Project to make bombs. And he also invented this. He was hoping that the molten salt reactors would be used to make commercial electrical power. But what happened was they needed the water-cooled reactors to make bombs. And so they pushed the molten salt reactors aside, and so they didn't build them. And so that was actually closed down in 1959. What they used to do at that laboratory is they would turn the reactor off on Friday afternoon. They'd go away on their weekend. They'd come back on Monday morning and turn it back on again. That's how safe it was. They just turn it off, go on the weekend and come back, turn it back on again. And so the thing is,
it would turn solid as it cooled.
Well, what happens is that, and they only discovered this once they had the whole thing set up, is that the molten salt, which is radioactive, to create the heat, what happens is when you draw energy out of the reactor, the molten salt warms up and makes power, okay, to run the turbine. And then they found out magically when they stopped extracting the heat, it would come down, the temperature would come back down, and it would reach its own equilibrium. if they just left it alone. It would just sit there quietly until you started taking out more heat again. And so it's a miraculous process, but like I say, it was invented at the Oak Ridge National Laboratory, which is a humongous facility. And if you go to my website, you'll see a big photograph. The photograph that I have on my website is not even the entire campus. It's acres and acres of big facilities. Of course, it's still there. I think it may be the largest laboratory, nuclear laboratory for sure in the United States. And so I didn't invent this. It was invented by scientists years ago.
This salt, or what did you call it again? The fluoride mixture?
Molten salt is fluoride and some other chemicals.
Does it go
lithium,
bad?
Fluoride and lithium.
Do they have to replace it? Does it go bad? Does it break down as compounds to where you're always having to get rid of it and then start over again with new stuff? Or is it always going to keep doing that? Turn it hard, turn liquid, turn it hard, turn liquid.
Oh, no. Once you get it going, it doesn't turn hard again. It always stays a liquid. Okay. The temperature can go up and down, but it remains a liquid unless it escapes.
Because Warren, you said if you accidentally left the door open, was your analogy, and it spilled out, it would stay contained. It wouldn't be up in the air. But I just assumed that meant that it would turn hard, but you're telling me it wouldn't. It'd just be this ooze, the salty ooze everywhere.
It would only turn back to a solid if it escaped out into the environment. And that's the safety issue, because it turns back to a solid and then it doesn't go anywhere. So that's the safety issue. But in terms of the reactor, it would stay a liquid and it would stay warm, and so that's the safety feature. Now the thing is that what we would add to the would actually make the reactor run would be thorium. Okay, thorium is number 90 on the periodic table. Number 92 is also radioactive. Those are the uranium, which are the only two naturally radioactive materials on the planet, thorium and uranium. Now, there's this amount of thorium, okay, about a golf ball size amount of thorium will provide all the energy that you could possibly use in your entire lifetime. Not you and me, Charlie, but a 5-year-old. All the energy the 5-year-old would use in their entire life, this much thorium will create that amount of power. Okay, and there's 4 times as much thorium on the planet as there is uranium. And the thing is that the thorium has already been mined. Okay, because when you mine something else, thorium is ubiquitous. So when you mine something else, you get thorium whether you want it or not. Okay, it sparkles in the dark. It's a little radioactive, so you have to keep it in the thorium pile. Okay, and monitor it. Okay, but it's already been mined. There's enough thorium already been mined to run the entire United States for 100 years. The thing is that the mines have to contain that material and put it under security because it is a little radioactive. So the thing is that they will pay me, the mine will pay me to come and get it from them. It's a nuisance for them. There's no current, I'm the only one that has a use for it. So there's no market for it. It has no market value. So the people who have the thorium will pay me to come in a dump truck and haul it away for them. And the processing of the thorium is far less of an issue than refining uranium for water-cooled reactors. Something else that's very important I should get in here is that I think most folks are aware that there's an issue with the waste material from water-cooled reactors, okay? Wherever there's a water-cooled reactor, there's waste that comes out of that reactor.
Right. And you have to store it underground for 1,000 years. And that's why everybody freaks out about nuclear power.
Yes. And the thing is, it's actually 10,000 years. Okay. And so that waste will be around.
10,000. What's a few thousand amongst friends?
Yeah, that's right. But the thing is, I can take that waste material and I can use it as fuel in the molten salt reactor. We will burn it up and it will be gone. That will be gone. We will use it as fuel. Now, I have to say that the molten salt reactor does have some waste to it, okay? But the thing is the waste of the molten salt reactor is 4% the amount of waste from a water-cooled reactor, and the waste from a molten salt reactor will be a hazard for 300 years. So you have to deal with it for 300 years. But after 300 years, it'll no longer be harmful to humans. So 300 years as opposed to 10,000, I think that's a big cost issue as well, because it'll be relatively easy to deal with.
How much, let's say, per plant? Let's give me an idea of a box truck full of this thorium waste that has to be disposed of for 300 years after a year of use, or can you give us an idea how much waste is there in comparison to uranium?
Okay, the waste from the molten salt reactor is only 4%.
That didn't tell me anything, because I don't know how much it comes from a nuclear reactor either.
Oh, okay.
Can you give me an idea? Is it a couple of Walmart semi-truck loads full, or what per year? What is it?
No, not even. A large dump truck, okay, per year from the molten salt reactor, and we'll contain it in vessels similar to the ones that they currently use for the water-cooled waste.
And that's only 4% of the uranium waste, and it's a large dump truck full per year.
Correct.
From one plant.
From one plant, yes.
So I had no idea that there was that much nuclear waste that we're hiding away for 10,000 years, and I have no idea where.
Oh, it's scattered all around. Wherever there's a nuclear reactor, the waste products are in the parking lot in special metal containers. So there's thousands of tons of it spread wherever there's nuclear reactors. There's thousands of tons of it spread around.
And that's okay. So that's reality. I'm still hearing many say, "Oh, nuclear power is the answer," and I always bring that up all the time. That's some monumental waste that's being produced there that is incredibly dangerous. Where are you hiding it? Where are you putting it? Oh, we'll bury it in the desert. Really? They tried in Nevada. They were pushing hard to turn some basically barren mountain there that didn't have much vegetation on it. They were going to turn that into a gigantic nuclear waste disposal area. And many in Nevada freaked out. Went, no, not in my backyard. Nobody wants it in their backyard. Can't blame them. Where do we put it all? So that's a very real concern for me when it comes to nuclear power. That's great that it's so effective and it's so efficient and it's so this, so that. But Richard's idea here, this is next level stuff. This is fantastic. And thank you for admitting that it's not even your idea. This has been done before. So it's been tested. It's been tried and it worked. It got abandoned for what reason though again? Remind us.
Well, the reason they didn't go with that, the safe process, is because at the time the United States was in a race with Russia to see who could make the most nuclear bombs. And so they went with the water-cooled reactors because they could extract plutonium, enrich it, and make nuclear bombs. And so that's why they didn't go with this process. Alvin Weinberg, the guy who was the big nuke guy at the time, actually he was in charge of the lab, and he wanted to build molten salt reactors to use to create commercial electrical power for the citizens of the country. But the thing is, the people who wanted to establish the water-cooled reactor projects, General Electric and other large international corporations, and once they established that industry, the executives have their feet up on the desk and billions of dollars are rolling in. They got no interest in changing anything, Charlie. And they see me as an enemy. And I don't mean that euphemistically. They see me as a threat. And I've had people in that industry here in California I don't want to explain too much, but or mention too much, but they make it clear to me that I'm an enemy. They don't want my word out anywhere. Do not talk.
Well, thanks for bringing that down on this show. Now we're the target too. Actually, that's that's why we're here. This is a ministry, this show. My producer Kirk and I, this is at this point not making a lot of money, this show. Yeah, we've been on the air for a year, but it's a very slow process because there's tens of thousands of people all of a sudden thinking that they can do this, and I'm one of them. But it's a labor of love. So this is what I want to do. I want to give exposure to people like you who have these great ideas and an excellent plan, and everybody who's already making a lot of money. I hate big corporations. I've had it. I'm sick of it. Let
me just mention a little bit about me. People ask me if I'm a physicist, and I have to say no, I'm not a physicist. What I am is I'm a builder, okay? And I built large projects. I built a couple of hospitals. I became a consultant. My first big consulting gig was for the city of San Jose when they expanded the airport years ago. And I helped them with that project, a big project. I poured enough concrete in that project to build 3 molten salt reactors, okay? And in the hospital projects, we ran enough piping and very sophisticated operations in the hospitals so building this nuclear reactors, for me, is I've learned over the last, like I say, I've been doing this for 4 years. I've learned that I can do this. And the thing is, I built large projects, so I know how to do that. I've hired engineers, many of them over the years, to build projects. Obviously, I've hired structural engineers to build different facilities. And I can hire physicists. I'm currently in conversations with a couple different physicists, so that's not an issue either. Richard. And one thing I want to mention is the reactor that I want to build will just be the prototype. What we'll do once we get the prototype under construction, okay, some distance away at a different location where there will be no radioactive material, we're going to build a robotic manufacturing plant to build modules, okay, to build these reactors, component modules that we can load on a truck or a railroad car. So what we can do is we can go to another site, we can pour some concrete, truck the modules out there, bolt them together, throw in some thorium, and we got another power plant. We're going to need hundreds of power plants to actually power the entire United States, and that's my goal. That's what I was
getting give me an idea of population or size of area that one of those plants would serve.
Okay, of course it's dependent on population density.
Yeah.
And so it very a lot.
Los Angeles.
For instance, to power the Bay Area, we'd probably need, state of California, we'd probably need about 40 power plants. Probably 5 or 6 of those would be in the Bay Area. The majority of them would be down in the LA area because the population down there is dramatically more. And so I'm thinking we're going to need somewhere around, well, let's say several hundred to power the entire United States. But the thing is, we'll replace all the other energy. So we're not just replacing the dirty, we don't have any coal left here.
Yeah, no coal-fired power plants, what's the
gas-fired.
Yeah, thank you. With the steam turbines and so on, that would take care of everything. So this petroleum-based energy production that everybody seems to despise and has become our enemy, even though it's very clean burning now. It's not like it used to be.
Well, the thing is, we can also avoid making environmentally hazardous batteries because the nuclear power plant doesn't close down when the sun goes down, and or if it rains. Okay, and so we don't need any environmentally toxic batteries to operate. I've already explained the safety issue, and the thing is, we get several hundred of these going, and the cost will come once we set up the plant to make modular components. The price of a reactor will drop exponentially because once we start building components, hundreds of them at a time, as anybody would know from manufacturing, that the price per unit drops dramatically when you start making hundreds of them instead of just one or two. And
here's what's beautiful about this. One thing I should
just throw out there for any engineers who happen to be listening, the efficiency of the molten salt reactor, they are 45% efficient. I won't talk about that much more because only engineers will appreciate that number, but that is far superior to any other source of heat energy.
We have a huge audience of engineers. Engineers seem to flock to the show. We have so many engineers, 3, maybe even up to 4 now, engineers watching this show. So I don't know. I don't think we have a lot of them. I am very interested in this because it sounds like you're already taking this to the county where you live, trying to get an audience with the Board of Supervisors in your county. This is something that, let me think of a good example. Pacific Gas and Electric is dominant in Northern California and horrible, just a horribly run company. And there's government regulation involved, so anything they touch, they ruin. It's horrible, not efficient, terrible, wasteful, just a bad service. Down in Southern California, you have Edison. But there are entities where the counties are producing their own power. Sacramento Municipal Utilities District comes to mind. East Bay Utilities District, eBay Mud, SMUD in Sacramento, SMUD. They are doing their own thing.
Little information though. On April 7th, 1977, Jimmy Carter announced that the United States would defer indefinitely the reprocessing of spent nuclear reactor fuel. So for the last 50, 60 years, we've had the ability to reuse the spent reactor fuel and use it all the way down to like 2%. But Jimmy Carter signed that policy that stopped all nuclear waste recycling.
Stopped nuclear waste recycling?
Yes.
Yes.
So we had the capability. Jimmy Carter stopped it.
Yes. Like we know that the molten salt reactor was available to build since the 1950s. And so at the time, there was a lot of discussion about doing that. How many of us were around in the 50s and sophisticated enough to even listen to that conversation. But the thing is that we had the capability back in those days, but like I said earlier, once the industry got established with large international, GE's not just a U.S. corporation. These large international corporations, once they get established and the bucks are rolling in, anybody who suggests anything different is an enemy. And so they treat them as an enemy because the big bucks is what it's all about. Everybody knows follow the money. And so that's what's going on. And so what I'm trying to do is, in my own way, is to get public opinion around to building the safe power source. And if I might elaborate a little bit more on me, I hate to talk about myself, but people ask me, what do I do? I mentioned that I built large projects and eventually became a consultant for the University of California, which is the largest builder in California and has been for decades. They got 13 campuses, and at any given time, they got billions of dollars worth of work going all over the place. I really appreciated that experience, and I have friends with the University of California to this day. And so I'm in the process of making some different presentations and trying to get some nuclear scientists with the university involved. But the thing also, I wrote a book on construction budget management. And what actually is going on here is the money. That and my formal education, by the way, happens to be in finance and economics. And I can hire plenty of engineers and physicists and a lot of them actually, to help build this project. But the real issue is getting the public on board. And then once it looks like we're getting things lined up with the Nuclear Regulatory Agency to pull a permit, then the venture capitalists will get on board. And
Heck yeah.
then I
if I had the money, I'd be throwing in. I think this is brilliant. I hope it does. How can we help? How do we find you? How do we get involved?
Okay, and I want to mention that I reject any government funding. I currently have a friend who does grant work, okay? And she has encouraged me to take some grants that are available for energy research, okay?
Yeah, but that's tied in with the government then. Then you're beholden to them.
Yes, and she actually does this for her. That's what she does, is her profession. Is it
private money grant or is it government money grant?
Well, it's government money grant. And so the thing is that I totally reject any taxpayer money. Smart. I reject taxpayer money.
Everything they touch, they ruin. You can keep them out of it. That's a great idea. But then you're competition against them, aren't you? So how can we get involved and how can we help? Where do we find you?
Oh, well, you could visit my website at ThoriumElectricUSA.com, and don't be shocked when I start off with some politics, because like we talked about earlier, you can't do this without being involved in some politics. And so rather than hide it, I just get it out there up front. I'm a conservative, I'm a builder, and so that's me.
It's fantastic. ThoriumElectricUSA.com. And my producer Kirk has it down below and also in the show notes. So find out more about this, because I think it's fantastic, and how we can help, I don't know, but at least get involved and learn. Thank you, Richard Lingensjo. It's been a pleasure. Thank you for the education, sir.
Thank you, Charlie. I enjoyed it.
Good. I'm glad you did.